You guys done? Okay, so I just wrote here extra office hours. So that means extra. So I also have my office hours for Friday, which is like right before our class. I thought it is showing. Yeah, my cable was giving me a hard time. Oh, the projector was off. Okay. Okay. So you can see the text momentarily too. So today I'll be at my office 4 to 5 p.m. I also be there till 7 or 8, but I scheduled office hours for my other class. So if you have a burning question that you want to ask me, you are welcome to just stop by any time this evening. But specifically 4 to 5, I devoted to this class, so we won't be interrupted with non-CHEM101 questions. And also tomorrow I'll be at my office 10 to 12 p.m. and also 4 to 5 p.m. specifically for this class. But tomorrow I have a busy day. Basically I'll be on campus the majority of time. But these ones again some extra times. And then again Friday before our class from 10:30 a.m. I'll be at my office. But I have my office hours for this class specifically at 11:30. But you're welcome to stop by earlier too if that doesn't work for you. So I'm going to also write Friday. So this is my usual office hours, which is 11:30 to 12:30. Of course, that is 11:30 a.m. So to 12:30 p.m. Any questions about office hours? So just a reminder that you have until Friday evaluation to fill out the student evaluations. And I just asked you if you have like criticism, be fair and tell me why you wrote that. I have some students putting like some reviews for me and they say she gives lots of extra credits, which is nice. She's really fast in responding emails, which is nice, but somehow students are struggling and I don't know why. And they rated me as awful. So if you want, I don't say that you should give good evaluations. This is anonymous, doesn't affect your grade. And it's just for me to improve my teaching style. But if you don't tell me what is the issue, how can I improve, right? So feel free to just have like negative comments. But also, if you have something positive to say, just include that too. Because I just become really down when I hear bad comments. And specifically without giving some reason, right? She's awful, period. So why? Just tell me so I can improve myself, And also, if you have something nice to say, I appreciate if you write that as well. So I just won't be attacked. I also have some good things as well, so I can hold on to. And the deadline is this Friday, and as I said, this is basically for you. My life goes on with or without a student evaluation, and that is basically for you. So you inform instructors and your professors how they can do better, and what they did you didn't like, and what they did you liked. So as I said several times, make sure to be fair and tell the things that you like and also tell the things that you didn't like. As I said, I appreciate, if you just tell me why you didn't like something so I can improve, okay? Without that, I cannot improve because I don't know what was the issue, Any questions about office hours or student evaluations? Okay, so if no questions, I'm going to have like these slides that I prepared for resume recording. Okay. I go here. I'm doing things here you cannot see, but I'm just like uploading our lecture here. Okay. Go to first slide and it's recording as well. Okay. So in our exam, in your final exam, you're going to have combination of theoretical questions, kind of like conceptual problems or questions, and also problems. And I do that because if you're struggling with the math, you still can get credits for definitions, okay? And I give you numerical problems in case you don't like this, you have like some points to get from those. So make sure you study these things, and I'm going to just briefly review this and just try to solve more problems that you're going to see in exam. But remember, what was pure substance, what was mixture. Pure substance can be categorized to elements, compounds, right? And then later on, we learned that compounds. Okay, so the periodic table, and I went through that last session. As I said, that's really important for you to identify what is metal and what is non-metal, okay? So remember that, you know, on the except hydrogen here, right? And you had like this zigzag here, that this is basically these elements, the metalloids are distinguishing, or they're like the border of metals and non-metals. And here you see that, you know, boron, remember boron is a metalloid, and silicon, right? So if you remember these two are metalloids, remember the first one was just one element that was metalloid in group 3A. In group 4A you have two, in group 5A you have two, and group 6A and 7A you have only one. And that is the zigzag, that you have metalloids. Above that you have non-metals, below that you have metals, and hydrogen is an exception too. Okay, so this is really crucial for you to know. Questions? And just feel free to raise your hand or like ask me if you have any questions. I'm trying to be fast to cover these materials. Let me go. So I asked you to read this slide word by word. I asked you in the exam, true or false question, which of the following is not correct, which one is correct. So make sure to read that really well. And as we said, I just showed you the location of metal, non-metals, metalloids in the periodic table. And as I told you before, metals have the tendency to lose electrons. Non-metals have the tendency to gain electrons, so that is really important. And metalloids, we also call them semiconductors because they are like between metals and non-metals. And in general, most metals, they are really good conductors of heat and electricity, but non-metals, they're not. Okay, and metalloids are in between. Make sure to study this slide word by word, as I said. And we had chemical formulas. So chemical formulas represent how many elements are in the compound, and depending on what type of chemical formula you have, whether it's empirical or molecular, depending on which one you have, you may have the exact number of atoms as well. So empirical formula was the simplest. Maybe I just move my screen a little so I have more space. Simplest whole number ratio between elements. For instance, CH. It just tells me for each carbon I have one hydrogen. But molecular gives me the actual number of atoms. The actual number of atoms from each element. Each element. For instance, C6H6. That is a molecular formula. It tells me exactly I have 6 carbon atoms, exactly I have 6 hydrogen atoms. But empirical formula just gives me the simplest number. So I give you something like this, and you saw that in your exams. Which of the following is not an empirical formula? And I give you like CH2, C2H, C2H3, C2H4. Which one is not an empirical formula? C2H4. Exactly, the last one, because you can divide both of these by 2 and write it simpler, as long as you can. And as we said, you should have whole number. You cannot, you cannot write this as like CH1.5. You should be having whole numbers, because having 1.5 hydrogen atoms doesn't make much sense. So whether you have like 1 hydrogen or 2 hydrogen is whole number. Any questions? Are we good? Yes. Okay, so polyatomic ions. I talked about cations and anions in the previous lecture. So cations, they had positive charge. Anions, they had negative charge. And we talked about metals having the tendency to lose electrons, 1 or more, to form cations. Anions, basically non-metals, have the tendency to gain electrons and have negative charge. And is it clear? Because we said protons, they have 1 proton has a charge of +1, 1 electron has a charge of -1. So in general, atoms are neutral. But if an atom loses 1 electron, it loses 1 negative charge, so the number of protons is more, so now it has positive charge. But for instance, chlorine, if it gains 1 electron, now it has 1 more negative charge. That's why it becomes like an anion and the charge is negative. So that was, cations and anions that I talked about last class. And I told you previously about polyatomic. So poly means more than 1, right? 2 or more. Atomic, it means that it has like more than 1 atom. And it's the ion, so it has a charge. For instance, acetate, and I'm trying to zoom this better, okay? Acetate has charge of -1. Carbonate has charge of -2 or 2 minus, and then you can see the charges here, right? Or peroxide, it has charge of 2 minus. And previously, before me, students in 101 class had to remember this. But I think it's not fair for you. If you can't just use it, you can just refer to this table and just look up for the polyatomic ion that you want. So maybe it's the bad thing that I'm doing that give you this, maybe not. But I'm going to give you that in the exam, so you don't have to worry about it, but you should be able to use it. And I'm talking about like writing compounds and naming compounds momentarily, so we go through some examples. But in general, what is the definition of a polyatomic ion? An ion composed of a group of atoms with an overall charge. If I give you NH4 by itself, and I said, is this a polyatomic ion? Is this yes or no? If it doesn't have a charge, it's not an ion. Okay, you should have a charge in order to have a polyatomic ion. Okay, any question about this? And in the exam, just pay attention. If I ask you for chloride, can anyone tell me what is the formula for chloride? Cl minus, exactly. You have only 1 atom when you have IDE attached to chloro, So don't get confused. Here you have like IDE too for some of these, but they are like peroxide, cyanide, or hydroxide. But for chloride, if you have only 1 element, 1 atom, Cl minus, that would be chloride. If you have ClO2 minus, it would be chlorate. So sometimes you know the answer, but you just don't pay attention. And this is the other thing I cannot emphasize enough. In your final exam, when I give you the exam, read the questions well and read all the answers. Even if you're sure that you know the answer, right? Sometimes the students, they see the first one, A, is the correct answer, and then they move on. And then if you read all the options, you see that also number 2 is right. Also number 3 is right. And then you realize I asked you which of the following is not a polyatomic anion, right? So make sure to read questions well. Any question about this? So now I guess here is a good time for me to talk with you about naming or like writing ionic compounds. Remember ionic compounds? As I said, we have a cation in general plus anion. And 99% of the time, you see that in this table, the only cation is ammonium. So for that matter, 99% of the time, your cation is a metal. Okay, so I tell you, write the ionic compound that forms between iron 3, and sulfite. What you do, you write iron 3. This 3 means that iron has a charge of 3+, and that is a metal. It should be a cation. Metals lose electrons. And then sulfite. Here you can find it and make sure to just choose the one that corresponds to sulfite. Okay? I mean, it's just like so unfair, or I don't know, it's just like you feel bad after the exam that you, oh my God, I knew what was sulfite, I just chose sulfate. You know what I mean? So make sure to also pay attention. And you have two ways, as I said, to write this. When you have, two, I guess the simplest way is that, first of all, when you have polyatomic ion, you consider the whole group of atoms, all of these have charge of 2-, not just sulfur, not just oxygen, all of it. So you treat that as if you had just chlorine, okay? Treat all of them united. And you put these 3 here, and you put these 2 here. So you write that as Fe2SO3 3. And you can also check, you have 3 sulfite that has charge of 2-, so in general you have -6, right? And you have iron 3, you have 2 of that, so you have +6, so you're good. If you do the same thing that I did here and then you get +4 for iron, you did something wrong. Because ionic compounds, they consist of charged particles, but overall they're neutral. Because when I write, for instance, MgCl2, do I write a charge here? No, right? So they're neutral. They don't have any charge. Are we good with this example? Any questions? Now, if I want to name this. So when you have metals that they have only one type of charge, remember what they were? Your group 1A, your group 2A, aluminum that had charge of +3, zinc that had charge of +2, and silver that had charge of +1. When you have those, you don't have to use Roman numerals because they only have one type of charge. And I always say, if you want to, refer to me in the department between the faculty, since there is one leader, you don't have to tell my last name, right? But if you have other professor that their name is Mike, right? And then there are several Mikes in the department. So you should refer to their last name to distinguish. So that is the same story here, because these elements that I mentioned, they form only one type of charge. You don't have to write that in parentheses, okay? But iron, it has like 2 types of charge. So I should specify which one is it. Is it iron 2 or is it iron 3? And anything except those elements that I just mentioned, those metals that have only one type of charge, anything else that I give you, they have multiple types of charge. So you should write the charge with Roman numerals in parentheses. So that's talking about the metals and writing their charge in parentheses. The other thing, if you have polyatomic ions, or specifically polyatomic anions, you don't change them. So here, I just say iron 3 sulfite. So naming polyatomic ions or ionic compounds that they have polyatomic ions is fairly simple because you don't have to do anything. But if you have, for instance, trying to scroll, okay, it doesn't let me. If I have NaCl, what is the name of this? Exactly, sodium chloride. Remember, and I always tell students to remember one example, and that helps you in exam. If you remember, if you forgot how to write ionic compounds, table salt, sodium chloride, maybe you heard before, so remember that example. So you have name of the metal or cation, base name of nonmetal plus IDE. Okay? Questions? Maybe, okay, here. I was like, I'm sure I included this slide. So elements can be atomic, molecular. Can anyone tell me what was molecular elements? O2 N2, H2, and all your halogens, which are fluorine, chlorine, bromine, right? Iodine. So these are your molecular elements, and you should know that by heart or memory, okay? And I ask you in the exam, which of the following is not a molecular element? And I say oxygen, nitrogen, hydrogen, boron. Which one's the answer? Boron is not a molecular element. And also compounds can be molecular or ionic. So can anyone tell me what were ionic compounds? Exactly, 99% of the time there are metals plus non-metals. You have only one exception, which was NH4 plus. So if you have, for instance, NH4OH, this is also ionic. Okay, so in general, ionic compounds composed of cations and anions. Good? But molecular elements, they are like, non-metal plus non-metal or metalloid plus non-metal. So if you just remember this exception, ammonium, NH4 plus, except that exception, if you see metal plus non-metal, that is ionic. If you don't see a metal and you don't have NH4 plus, you have molecular compound. Good? And I'm going to go back to the slides that I just, okay. Okay, and here, this table you don't have to remember, but I just listed that so you have familiarity with it. And you see you have chromium, iron, cobalt, copper, mercury. These are transition metals, but tin and lead, they're not transition metals. They are main group elements. So the metals that have multiple types of charge are not necessarily transition metals. Because I asked true or false questions from this, I emphasize that. And also tin, it can have charge of 2 or 4. And this one I talked about in detail previous class. So Hg2, 2 plus, we call that mercury 1, because you have 2 atoms, 2 Hg atoms, and you have 2 positive charge overall, so each atom has charge of +1. Does that make sense? So you'll see that in the exam. And if you can't distinguish between mercury 1 and mercury 2, you most probably get that question wrong. But the others, based on the anion, you can find out the charge. For instance, if I give you SnO2, and I say, what is the name of this compound? So the way that you can do it is that you remember that I asked you to remember the charge of oxygen. What was that? 2 minus. So you have 2 oxygen that each of them has charge of 2 minus. What is that? -4. So you want to have a neutral compound, right, without a charge. So how many positive charge you should have? +4, right? So your tin has charge of +4. Tin, 4, and you see 4 like that, right? Oxide. So this is 1, this is 2, and we write that in parentheses. And this is 3, and then this is 5, and when you have like one line before it, it would be 4. And this is the maximum you need to know for your exam. 1, 2, 3, 4. I'm going to write that here too. 1, 2, 3, 4, 5. I don't even think that you need 5, but it's good to know that it's 5, and then when you put the line after that V shape, it would be 6. But that is all you need to know in the sense of Roman numerals. Any questions? So let me write this here. What is the name of this compound? copper oxide. What is wrong with this name as of right now? Is copper among the ones that I told you they have just one type of charge, group 1, a 2A, aluminum, zinc, silver? Is it among those?
No, it's a transition.
So you should have, and you see this is another thing. So zinc and silver are also transition metals, but they have one type of charge. Okay, so make sure, necessarily the ones that have one type of charge, they're not necessarily main group elements. And the ones that have multiple types of charge, they're not necessarily transition metals. But your friend is right, most of the transition metals, except zinc and silver, they have multiple types of charge. So what is the charge of oxygen? So what should be the charge of silver? 2, right? So this is copper 2 oxide. So if I write copper 2 and I write oxide, if I switch these, I can then simplify them and write that CuO. And after this lecture, as I always emphasize, you should go back and study solve problems, because you may think that you learned in the class, but you see that I can ask a question that you don't know. So make sure to study these for your final, and make sure to study for your final exam. So fluorine, chlorine, bromine, iodine, oxygen, sulfur, nitrogen, when they form charges, and I talked about these during the previous class, we call them fluoride, chloride, bromide, iodide, oxide, sulfide, nitride. And specifically for these 3, you can easily confuse them with the polyatomic ions, right? Nitride, sulfide, peroxide, hydroxide. So make sure, as long as you know this, and I give you the table of polyatomic ions, you should be able to identify those. Any questions? Good. And here I have like this slide for naming ionic compounds, but I talked about that already. And here also, we have like the Roman numerals. This is just a summary of what I talked about. So if you want to name molecular compounds, if I have BF3, as I told you, you can also have metalloids. So don't get confused. How would I name this one? Anyone? Hopefully I can then go back to my slide. Do you remember these? Mono is 1, di is 2, tri is 3, tetra 4, penta 5, hexa 6, hepta, octa, nona, deca. And I asked you in your exam, which of the following is not being used while naming molecular compounds? Nano. Nano is not being used. Or like bi. Bi means 2 in other contexts, but not here. We use di, okay? Or like, I don't know. I can change any of these. So make sure you know these well. And if you have, I guess the best way to learn this is with an example. Can anyone tell me what is the name of CO2? Carbon dioxide, right? Probably you heard that in news too. Destroying our universe. So you have one carbon at the beginning. That's why we don't write mono at the beginning. When you have one atom at the beginning, you don't write mono. So you start with carbon and you have 2 oxygen, you write di, and then base name of non-metal plus IDE. Or like CO would be carbon monoxide, or BF3 would be boron trifluoride. Does that make sense? Okay. So make sure to also study that. And when I was lecturing this, I included so many examples. So if you're struggling, just go to the examples and make sure to know the answers. So formula mass, you're going to see a question about formula mass. The unit of formula mass is atomic mass unit. And I talked about atomic mass unit during our previous lecture. Since I want to solve some problems for you all, I'm going to just skip it. But remember that if I asked you to calculate formula mass for BeOH2, for instance, what you do, you say formula mass equals, you count the number of atoms of your first element. How many Be do you have? 1, okay? 1 Be plus how many oxygens do you have? Exactly, you have multiplied this 1 here by 2. It would be 2 multiplied by oxygen. How many hydrogens? 2, exactly. And what you do, you go to the periodic table, locate beryllium, and then read the number below it, which is the atomic mass. You do the same for oxygen and read that, and then you do the same for hydrogen and read that. And when I write your exam, you know, I try to have like options that make sense. So what I do, I solve the problem one time with boron, one time with bromine, one time with Be, and one time with some other element. So what I'm saying is that make sure, and that's why when you solve the problem wrong, you find the answer, because I think how students can, you know, not pay attention in the exam. So when you have Be here, make sure to read the atomic mass of beryllium, not boron, not, you know, bromine or any other element. And then you substitute these values here, right? And make sure, first of all, make sure to bring a calculator. If you don't bring a calculator for your final exam, you know, my TA might bring one if she shows up, but I don't have calculator for you guys. So make sure to bring calculator. And also, if you have a calculator that it doesn't have parentheses feature, make sure to enter the numbers in calculator separately and then add them together. If you have one of those elementary calculator, when you do 1 multiplied by 9 plus 16, it just does it in the order that you give the number, you know. And again, it would be so upsetting if you know the answer, your solution is right, but you just put it in calculator wrong. That's why I always tell students, after you put the number in calculator, just look at this. You know, this is roughly, you know, 9 or 10. This is like 32. This is like 2, you know. So even if you consider that as 10, it would be like 34 plus 10. So your answer should be in the order of 44, you know. I mean, I had like lots of error doing this. But what I'm saying is that if you get 142, you know you did something wrong, okay? So for the questions that you know, make sure to, you know, get the points for the questions that you know. Any questions? Good? Okay. Avogadro's number. Remember, 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. And as I said, if I ask you, you know, how many oxygen molecules exist in 50 grams of O2. Remember these types of conversions, and I have in the next slide a summary of how you solve these problems. But in general, we had like something Avogadro's number. The other thing that we had was molar mass. Molar mass is mass of 1 mole of anything. So if I'm talking about molecules, it would be mass of 1 mole of that molecule. Okay, if it's like ionic compound, it would be mass of 1 mole of that ionic compound. Or if an atom, it would be mass of 1 mole of that atom. Okay, so here I asked how many oxygen molecules. Okay, so I say how many oxygen molecules. And when I ask something like this, right, and then you have like a gram or like moles of something, you remember Avogadro's number. That number is really large. So if the answer is like 5, right, you know that you didn't solve the question right. So anything that you want to find, as I always mentioned, right here on the left side, equal sign what you are given. What do you have? Grams of O2, right? So you write it here, equal sign 50 grams of O2. Okay? And you write a conversion factor. In the denominator, you write the thing that you want to get rid of. In this example, I want to convert grams of O2 to moles of O2. Okay? And to find molar mass for the compounds is the same procedure as formula mass. Just the units are different. Unit of molar mass is grams per mole, but formula mass, as we wrote before, is atomic mass unit. So you say O2 equals 2 oxygen atoms, and this is 16. That would be 32. Okay, so 1 mole of oxygen has the mass of 32. Any questions so far? So you do grams to mole conversion by molar mass. And now I told you 1 mole of anything, including O2 molecules, has 6.022 multiplied by 10 to the power of 23 of that thing. And as I said, this is number of O2 molecules. So remember, Avogadro's number is a number, is like dozen, that is 12 of anything. Okay, it's not grams, it's not kilograms, it's not mass. You know, Avogadro's number is a number, but it's a really large number. So your final answer here would be 50 multiplied by 6.022 multiplied by 10 to the power of 23 divided by 32. And that would be your answer. And make sure you include everything when you put the number in calculator, and it doesn't hurt to just check the number yourself too. So here, as I said, if this number was 6, 5 multiplied by 6 is like 30, so you have 102. So this number roughly is 10, right? Roughly. So 10 multiplied by 10 to the power of 23 would be 10 to the power of 24. What I'm trying to say, if you put this number in calculator and then you get something in the order of 10 to the power of 22, you know you did something wrong, right? But this one, you don't need to worry about as long as you put the number in calculator right. But it doesn't hurt to check the numbers yourself too to make sure you didn't put them wrong. Sometimes when I just check the answer myself and I'm writing the exam, I realize that, oh, I didn't put this 32 in calculator, right? So it's crucial to do that. Okay, so here is a summary slide that I wrote for you before, and I emphasized that in the previous slide too, and I'm going to tell. So if you know these 3 things, you can solve the problems in chapter 6. First of all, you want to calculate molar mass of different species I wrote here. It can be compounds, it can be elements, it can be molecular elements, right? It can be molecular compounds, it can be ionic compounds, it can be polyatomic ions, it can be anything, right? As we said, polyatomic ions, since they were compounds that they lost or gained electrons, that electron doesn't do much to the weight of that ion. So you can also do that for polyatomic ions. So the unit is grams per mole. And this is another thing that is important, you know. Chemical formula gives you relationship between moles of your elements. If I tell you I have CO2, and I ask you how many moles of carbon exist in 20 moles of CO2. So you can tell me that in 1 mole of CO2, you have 1 mole of carbon, you have 2 moles of oxygen. So basically these numbers here, they represent moles. Does that make sense? So here you say how many moles of carbon exist in 20 moles of CO2. Now, how can I convert moles of CO2 to moles of carbon? So in 1 mole of CO2, how many moles of carbon do I have? 1, right? So you have 20 moles of carbon. So what would be the answer if I ask you how many moles of oxygen? And I ask oxygen atom. Oh, 40, exactly, because for each mole of CO2, you have 2 moles of oxygen, so you multiply this number by 2 here. So it would be 40 moles of oxygen. Are we good with this type of questions? So if you learn this, and I'm going to talk in our last class on Friday, that if you learn this, for reactions and chemical reactions, it would be the same, but instead of chemical formula, you have the balanced chemical equation. And you use the coefficients of the balanced chemical equation to write mole-to-mole conversion, but everything else would be the same. You convert grams to moles by molar mass, you convert moles to moles by the coefficients of the balanced chemical equation, and you convert moles to grams by molar mass. But this is kind of like the building block, if you will, of what we learned in this class. And also, as I wrote in the example before, when you want to convert number of atoms to mole, or number of molecules to mole, or number of ionic compounds to mole, number of students to mole, anything, number of anything is, 1 mole of anything is like Avogadro's number of that thing, 6.022, multiplied by 223 atoms. So you use whether this conversion factor or that, depending on, I can give you the number of molecules, and I'm going to write that real quick here. I say, how many grams of O, oxygen atom, exist in what should I write? 55 multiplied by 10 to the power of 25 oxygen molecules. So again, if you learned what I just told you before, I'm trying to move this. Okay. You say how many grams of oxygen, when I say O, I just mean atomic oxygen, right? Exist in 55.10 to the power of 25 O2 molecules. And that can be the question in your exam. So you say, you have number of O2 molecules, how can you convert that to grams? First, you should convert it to moles, right? Moles of O2 molecules. And it's important to write O2 or O so you don't get confused. And say 1 mole of anything is 6.022 multiplied by 10 to the power of 23 of that thing. And here you have moles of O2 molecules. You want to convert it to moles of O atoms. In 1 mole of O2, how many moles of O I have? So O2, it has 2 oxygens, right? So in 1 mole of O2, you have 2 moles of oxygen atoms. And finally, you convert moles of O atoms to grams of O atoms. How would you do that? Molar mass, right? And then you put these numbers in calculator and then find the grams of oxygen. I can give you this in exam. Instead of O2, I give you N2, or I give you NH3, The procedure is the same as long as you know. And finally, I just wrote the formula of mass percent composition, and I'm going to also talk about that in the next class because I didn't have time to go over it today.